All right, we're going to be looking at the introduction to probability. And if you take a look at that first page, just to go over symbolism real quick, this upside down U right here stands for and. This just means the probability of A and B happening. This vertical line is what we call given or conditional probability. The other term that we use is conditional. And what it means is the probability of B given that A has already happened. Now, an important distinction to be made in just general probabilities, independence and mutually exclusive. So let me talk about these real quick. Independence just means this: probability of A and B is a probability of A times probability of B. And the reason why it's slightly different than this is what it means for independence is that A had no outcome or no effect on the outcome for B. And the way it's talked about a lot is, let's say you have a jar full of marbles. You have some bag of marbles or something like that. So there's 4 purple and 3 black. So independence means if we take a black marble out of the bag, put it back in, shake it up again, then take another marble out of the bag and calculate the probabilities. That would be independent because when we take a marble out of the bag, so let's say we probability of picking a black, which is going to be 3 out of 7. We take that out of the bag, put it back in, and then take it out again. Because we put the marble back in, shook it up, and took it out, the probability here is going to be 3 out of 7. The probability here is going to be 3 out of 7. One outcome didn't affect the other. This also happens when you flip a coin. If you flip a coin, probability of getting heads is 1 out of 2. The second time, the probability of getting heads is still 1 out of 2. One outcome didn't affect the other. Just because you flipped heads in the first roll or the first flip of a coin doesn't mean you have heads for the second flip of the coin. If it was dependent, we would take this black marble out and then not put it back in and select it again. So what would happen is we would have a 3 out of 7 chance the first time to get a black marble. We'd only have a 2 in 6 chance the next time because a black marble has been removed. So that's the idea behind independence. Now, mutually exclusive means the probability of A and B is equal to 0. You cannot have both of them happen. So let's say you take the dice. What's the probability of rolling a 2 or let's just say what's the probability of rolling, so say what's the probability of rolling doubles and odd? Right. Are there any doubles that are also odd numbers? 1 and a 1, 2 and a 2. When you add them up, the sum is not going to be odd. So this is an example of something that can't happen. They're mutually exclusive, which means these two things cannot happen. And that's what they mean by mutually exclusive. Now, in general, for the rest of probability, these are the two main pieces to know: mutually exclusive, independence, and this formula. It can get you through most of what you need with probability. So here you have a bag of 20 marbles. What if probability of select 2? And notice here we put it back in. So what's the probability of select 2 blue? Well, that's 5 out of 20 for the first selection and 5 out of 20 for the second selection. And that's because these are independent. All right, and they're independent because of we put it back in. We don't put them back in, and we have a 5 in 20 chance the first time, but there's only, if we select the blue, a 4 out of 19 chance to get the blue one the second time, because there's only 4 blue marbles left in the bag and only 19 total marbles left in the bag. So this is what they call dependent. And these are two good examples, just typical examples, just marbles in the bag, kind of like we talked about before. Now, what I'd like you to do is skip over this section and go to lesson 3. So once you're done with those notes, pause the video, go to lesson 3. So hopefully you got this from me from the front of the room. So we'll take a look. Professor needs to have 2 kids move a table. There are 15 females and 10 females. What's the probability of both people that he selects are boys from the class? So there are 25 kids in the class. So what's the probability, again, of 2 males? This is probability of a boy and a boy. Okay, or we'll use that upside down U, which is, so the first is 10 out of 25. But let's say you're one of the males that's picked. You're up in the front of the room. There's only 9 males left in the room, and there's only 24 people left to choose from. Now, notice I'm not doing any of these multiplications. I should make a note of this. You can just leave it in this form. This is the final answer. This works perfectly fine because it shows and understands understanding. I'm not really testing your ability to multiply fractions. So just leave it just like this. So you're given a 5-question quiz. 3 problems are true, false, 2 problem multiple choice. So again, this is a situation where they're independent. One outcome does not affect the other outcome. So if you have 3 true, false, you have a 1 in 2 chance of getting all the true, false correct. So these are the true, false questions. And you have a 1 in 4 chance of guessing on the multiple choice. So the probability to get them all correct is just multiplying them all together. So again, here's the 3 multiple choice, and here's the 2 multiple choice, and here's the 3 true, false. And again, they're independent. One outcome did not affect the other one. Just because you got one question right doesn't mean you got the other question wrong. Now, this is where we are going to get into just understanding tables. So if 2 different deaths are randomly selected, what's the probability that both were intoxicated? So both being intoxicated is here. So we have 59 out of 985, but we have that twice, right? So we're going to pick two different deaths. So 59 out of 95, now we have one less death and one less situation. So this one here, given the fact that the pedestrian was intoxicated. So I'm going to write this down. So probability that the driver was intoxicated, given the pedestrian was intoxicated. So symbolically, this is what I'm going to look, and this is that given. See the word given here? So this is that given condition. Now, I'm not going to use the formula because most of the time we do a given or conditional probability, these charts are a lot better. So what's the probability that the driver was intoxicated given the fact that the pedestrian was? So really, the way I like to look at these problems, the way I like to do these problems is I like to use the highlighter. So given that the pedestrian was intoxicated, so we're only looking at this section right here, right? So 59 is our 325. So this is going to be out of 325 because we're only looking at that certain section of people that are intoxicated, pedestrians intoxicated. What's the probability that the driver is intoxicated? Well, now that's going to be 29, right? Because it's, or sorry, 59. Because it's these people are intoxicated only given this situation. So what is the probability that neither driver protects if you randomly select 3 accidents? So now this, so we're not doing a given, or so it's not conditional, but we have 3 accidents and neither one. So if we want to look at neither, we're going to be over here at this 581. So this is going to be 581 out of the 985. But we want to do 3 accidents. So there's, and then 579 out of 983. Again, don't go and multiply all this. You don't need to. Just kind of leave it like that. These I'm going to leave it up to you guys. I'll put the solutions up in the back of the room. Good luck. Let me know if you have any questions, but it's all kind of the same, general multiplication type stuff. If you have any questions, let me know.